Hello again. I'm Dr. Randy Kearns, your professor for Management 4450, 5450, and today we want to talk about earthquakes for our disaster course. So as we go through the content, again, I'll follow the similar format. I want to cover the terms that are critical to understanding the content. We'll talk a little bit about what causes an earthquake and how that science has evolved, particularly as it relates to what we understand. Where do earthquakes more likely occur? And then how bad can it be? And then we'll also talk a little bit about injuries, self-protection, and then business continuity planning. So we want to start our presentation by talking about key terms. An earthquake is a shaking of the surface of the earth resulting from a sudden release of energy. The exact point of where that release of energy took place below the surface of the earth, that calculated point is called the hypocenter. The point where that energy first began is called the focus. But again, we primarily refer to it as that calculated point, which is known as the hypocenter. So that's maybe some distance below the surface of the earth. But if we measure to the surface of the earth exactly where the energy release took place at the surface of the earth, we'll call that the epicenter. The distance between the hypocenter and the epicenter has a significant bearing on how much damage we may see expressed. The moment magnitude may be very high, but because the depth of the earthquake, the distance between the hypocenter and the epicenter is substantial, we may not see as much damage expressed on the surface of the earth. Conversely speaking, if the hypocenter is very close to the epicenter, we may see a substantial amount of damage. Again, we'll talk about that later. But if that earthquake occurs offshore and under the ocean, that sudden change in the topography under the ocean may lead to a very large wave being produced that ripples out, and that's referred to as a tsunami. We actually have a separate section coming up on tsunamis and volcanoes. Just understand that there's some association between tsunamis, volcanoes, and earthquakes. But for the purpose of our lessons this week, we're primarily going to focus on earthquakes this week and then later volcanic activity and tsunamis. I also want to talk about the process of where non-cohesive soil, and we're talking about things like sand, but it loses shear when it's being shaken, and it really functions more as a liquid. That's referred to as liquefaction. That can have substantial impact on how structures hold together or fall apart in the face of an earthquake. And then as far as foreshocks and aftershocks, we don't really know when a foreshock has taken place until an earthquake takes place. If there are tremors that occur, if you ever live in the west coast of the United States, or particularly in Hawaii, every several weeks you'll feel small tremors. But it's only later, if there's a very large earthquake, that we believe that tremor was actually a foreshock foretelling us that large earthquake was going to take place. That is why whenever we have tremors, we are concerned that maybe it's foretelling us of a larger earthquake. And as we better understand the science, we are able to better predict if that tremor is just a tremor, or if that tremor is actually potentially going to express itself as a large earthquake later. After a large earthquake takes place, there's some ongoing movement. Those follow-up tremors that do take place following the original, that much greater earthquake, those are referred to as aftershocks. Sometimes the aftershocks are very substantial in nature and are seen as ongoing a second and a third large earthquake. And we'll talk about that particularly when we look at the New Madrid earthquakes in 1810, 1811, 1812. So as we've tried to understand the science of earthquakes, it's relatively new in terms of what we understand, and more concretely can best explain what takes place. But in 1871, a Japanese a scientist by the name of Kujo was really the first to hypothesize that earthquakes caused the breaking of the ground and not the breaking of the ground causing the earthquake. Henry Reed, who was a professor and a scientist, in examining the 1906 San Francisco earthquake, and we have multiple short videos to look at as it relates to the San Francisco earthquake, but he was the first one to suggest that there may be a buildup of pressure that's taking place through movement of the earth, and as that pressure is released, it's expressed in what we otherwise consider an earthquake. So by 1912, Alfred Wegener proposed drift hypothesis as his working hypothesis, published a paper in 1915, Origin of the Continents. He hypothesized that the Earth at one point was one very large singular continent, and relying on the Greek word for all lands, he called that singular continent Pangaea. He used the work of a ornithobiologist, botanist, paleontologist, and paleobotanist, people who look at prehistoric ages, prehistoric plant life, particularly birds. And what he was able to do was identify certain species that there's no other explanation for how they wound up on two separate continents, other than at some point that those two separate continents fit together as one particular landmass. Arthur Holmes in 1929 talked about mantle thermal convection, this heating and cooling process that also further exacerbated plate tectonics, something that would later be known as plate tectonics. And then Hess and Dietz, 1961 and 1962, recognized and measured that there were places that the seafloor was spreading and splitting and moving. And by 1965, which really isn't that long ago, we began to embrace what is plate tectonics. Again, when Alfred Wegener first suggested drift hypothesis, that working theory, that hypothesis was not accepted by most in the scientific community. It was only through the subsequent work that we began to realize, he was right. And so if we take the continents and like a kid's jigsaw puzzle, kind of place the pieces together, you can begin to see how drift hypothesis works. Again, we've got a couple of videos that I've added to your site so that you should be able to see this in better graphic detail. But as I mentioned, there were certain types of plants and animals that the only explanation for how they could exist on these separate continents is for the continents to have existed at some point in a way that they either touched each other or were very close, so that the plants and animals could freely move from what we see one continent today is to another continent, because the continents were in contact with each other, Pangaea. And so with plate tectonics, there are a couple of different ways that plate tectonics occurs. depending on how the plates come in contact with each other. In some cases, they're spreading apart, known as divergent plate boundaries. In some places, they're moving closer together, with one moving over top of another. That's referred to as convergent tectonics or convergent boundaries. And then transformative boundaries are where plates are moving north to south in an opposite direction of each other. We see that as an example with the San Andreas Fault. And so how do earthquakes happen? Again, the focus is that centerpiece, and mathematically we determine that focus and we measure that in what we refer to as the hypocenter. And then where the hypocenter translates to at the surface of the Earth, that's the epicenter. And again, the greater the distance between the epicenter and the hypocenter, the more area, and depending on what type of landmass exists, but the more opportunity there is to absorb some of that energy and express itself in less damage at the surface. But the closer it is, the more likely we are to see much greater damage at the surface. And so this kind of gives you an idea of how we have different types of volcanoes, how we have plate tectonics interworking with volcanic activity in some places, and other places more dormant volcanoes. But this is a good example of the interplay between how plate tectonics, volcanic activity, earthquakes, and at times tsunamis can occur, and how they're all interrelated. So when we talk about plate tectonics, really the best example we can use is what's referred to as the Ring of Fire. Now there are multiple plates that exist around the globe, but the most active of which is again, what's commonly known as the Ring of Fire, which is where there are a lot of active volcanoes in the boundary of the Ring of Fire. The Ring of Fire to the north is the Aleutian Island chain, which is a part of those western stretch of islands on the southern side, the southwestern side of Alaska, and then moving down the California coast, referred to as the San Andreas Fault. But the Pacific Plate is, again, a very large plate. It's a very active plate. And then over toward New Zealand and Indonesia, and then up to Japan and the Korean Peninsula. That area has been active, continues to be active, and we see a lot more activity there, both in terms of volcanic activity as well as tsunami and earthquake, things associated with the plate tectonics. Now, it's not to say that plates that are in other parts of the world aren't active as well. They're just less active and less likely to produce an immediate type of event as we have seen and continue to see in what's considered the Pacific Plate. And so this is just one more image highlighted in red, showing us where the most active plate activity has been located within the last 10 years. And again, as you can see, a lot of activity in New Zealand, Indonesia, Japan, the Korean Peninsula, the Aleutian Island chain, and then down the west coast of the United States. I will say, if you look at the west coast of South America, you'll also see a lot of activity that's occurred there and continues to occur there. We'll talk a little bit about Chile shortly, and the Chilean earthquake in 2010, I think it was, but that's coming up. Earlier, I talked about moment magnitude versus modified Mercalli when we were talking about terms. That release of energy, the moment of that release of energy is expressed in moment magnitude. Um, we've and that typically that has a fixed value. Sometimes if it's a very large number, we equate that with a very serious, a very dangerous earthquake. If it's a much smaller number, we typically equate that with a tremor. Moment magnitude provides a more precise measure than what has commonly been referred to as the Richter scale, but it's basically expressing in moment magnitude the amount of energy released. So today we're more likely to refer to it as moment magnitude rather than the Richter scale, but both are reasonably accurate and one has more of a reference to the other. Modified Mercalli is a way for us to express the intensity and the effect of the earthquake, how far reaching the earthquake was. In just a minute, when I talk about the New Madrid quake, while the New Madrid quake occurred in what's considered that boot section of Missouri and the west coast of Tennessee and the east coast of, when I say coast, I'm talking about the Mississippi River, but the eastern portion of Arkansas, just to understand, although the earthquake was there, we felt the earthquake, or the people who lived in New Orleans felt the earthquake at that time. Modified Mercalli gives us a way to measure the intensity of either how much damage occurred or how much occurred much further away from the epicenter of the earthquake itself. Moment magnitude gives us an idea of the release of energy at the hypocenter, the focus of where the energy was released. But it's a single measure at a single point. Modified Mercalli gives us an idea of how far-reaching the damage is. So both are important. Moment magnitude tells us the energy released. Modified Mercalli tells us how far-reaching it is. So as I mentioned with modified Mercalli, it gives us an idea of how far-reaching the damage is. It is a scale of 1 through 12. I just realized I've got some slides coming up that detail that a little bit better. So let me go ahead and move to what I have coming up about modified Mercalli in just a minute. So moment magnitude is truly a measure of the release of energy at the calculated center of where the energy was released. And again, mathematically, we calculate that to be the hypocenter. Wherever that occurred in the earth, that place on the surface of the earth above the hypocenter is the epicenter. The epicenter is typically where the most damage occurs, but as that damage spreads out, we don't really say it was a magnitude 8 earthquake. If the earthquake occurred in Los Angeles but was felt in San Diego, we'll report it as whatever the moment magnitude was in Los Angeles at a particular location, but as it spreads out away from that epicenter, we'll start to measure that in modified Mercalli. We'll talk about it in the context of how much energy was released. Just understand that's talking about the hypocenter and measured in distance away from the epicenter. When we talk about modified Mercalli, we're talking about what types of damage occurred in distances away from the epicenter of the earthquake. So the main thing about this slide is it gives us an idea of just how the exponential growth exists in the difference between a moment magnitude of a 5 on the Richter scale as opposed to a 7 or an 8, and the substantial amount of energy difference that does exist as the magnitude score goes much higher. With modified Mercalli, again, the idea here is to look at what people felt. Actually, there's um, a site on the U.S. Geological Survey to report I felt it, meaning I felt the tremor, and it helps them score modified Mercalli so that they can get an idea of how far out from the epicenter damage took place. How much did you feel? What occurred? What type of damage occurred? And the whole point here is to measure just how far reaching the effects of the earthquake were. So our first slide in modified Mercalli was 1 through 6. By the time we're getting to a score of 7, 8, or 9, we're talking about considerable damage, how difficult it was for people to stand, how much of the building was destroyed, maybe some bridges were destroyed, or buildings collapsing. And again, the closer we get to the epicenter, the greater and the higher the moment magnitude score, the greater the amount of damage that we're most likely to see. Modified Mercalli gives us an idea of how far reaching the damage can be once we can plot out the parameters of a score of 7 on modified Mercalli versus a score of 8 versus a score of 9. Again, I'll show you graphically what that means shortly. So the areas highlighted in red are the areas where we have had and continue to have the most seismic activity in the United States. If you notice, if you live in Hawaii, most of the state is red. If you ever visit Hawaii and you're there for any length of time, you'll feel a tremor. Chances are you'll feel small earthquakes from time to time that do occur there. If you ever live in California or Seattle or Portland, chances are you'll feel a small tremor during a year or 2 years of living in that location. Those are the areas that are most seismically active in the United States. Now, there are other parts of the U.S. that are also seismically active, or at least pose a threat to be seismically active. And we do have some history of earthquakes taking place in those locations. I mentioned New Madrid earlier, again, that eastern boundary of Arkansas, the Butte area of Missouri, the southern tip of Illinois, the western tip of Kentucky and Tennessee. That's the New Madrid zone. And we'll talk a little bit about the New Madrid quakes in just a minute. Then also, if you look over at Charleston, South Carolina, there's also a seismically active area there. I used to own a house in South Carolina. My doctorate is from the Medical University of South Carolina, which is in Charleston. That's the only time I've ever had to have seismic insurance. You know, I live in New Orleans. I have to have flood insurance here. When I lived in South Carolina, I needed to have seismic insurance there. So it does speak to at least the threat that exists and what we need to be prepared for as we live in different parts of the country and what types of threats may take place. This is just one more image in terms of where seismic activity has occurred and where the greatest probability may be of additional seismic activity. And again, primarily the San Andreas Fault, and then over toward the eastern side of Idaho, western side of Montana, Wyoming, down into northern Utah. And then again, the New Madrid quake area and the Charleston area. I will note that there has been some seismic activity before off the coast of New England. There was something referred to as the Queen Anne quake in 1755. So there has been some seismic activity in the Northeast, but it's rare. And it's been several hundred years since there's been anything substantial other than there was an earthquake in the Washington, D.C. area about 15 years ago. I was in a high-rise building in Chapel Hill where my office was at the University of North Carolina, and I felt the concrete building moving and shaking. I wasn't exactly sure what it was at the time, but again, no substantial damage, but I obviously felt it, and it did cause some damage in the DC area. So let's look at tectonic activity on the world map. Again, we have the Ring of Fire. It gives us an idea of what areas, what plates are seismically most active. If we look at world population and then compare that to the areas that have the most seismic activity, let's kind of lay this over top of each other. What we start to see here is there's a lot of areas that are substantially populated that are at risk from seismic activity. And so that's why, particularly when we're talking about areas in the Pacific Plate, Japan, the Korean Peninsula, Indonesia, these are areas where there is substantial population and where that substantial population can be at risk from the seismic activity. Again, just giving you an idea of the graphical representation of where the population is and where the seismic activity is. So let's talk about historical earthquake disasters. If we look at the top 10 disasters of all time in terms of lives lost, there are several here that include a cyclone, 2 floods. Everything else is an earthquake. And it does remind you that whenever there's a substantial earthquake, particularly if it impacts a significant populated area, it can lead to substantial amounts of morbidity and mortality. The number of people killed and the number of people injured in the aftermath of some of these earthquakes has been and continues to be substantial. The 2004 tsunami, Banda Aceh tsunami, and again, we've got a tsunami and volcanic presentation coming up, so I don't want to get too far ahead of myself, but it is important to note that that was an earthquake off the coast that led to a tsunami that came ashore in Indonesia, for that matter, Eastern India, Sri Lanka. There were people killed in a multitude of places in what was considered the Indian Ocean and the Southern Pacific Ocean. And again, I've got a little bit of information on that in this presentation, but there's additional information coming up later on when we get into tsunamis and volcanoes. So as we compare earthquakes, let's think about time of day, day of the week. We'll also talk a little bit about moment magnitude, and then modified Mercalli index, how many were killed, displaced, and any interesting fact. So we're going to start out with talking about the New Madrid earthquakes. There was a series of 3 earthquakes that took place between December of 1811, February of 1812. All 3 had a moment magnitude estimate of between 7.3 and 8.0. Modified Mercalli reached as far south as New Orleans. It was felt in New Orleans. There was some limited damage in the city of New Orleans. Actually, the new University Medical Center is rated for seismic activity. It was built to withstand an earthquake. But it was also felt as far north as New York City. There were also reports of church bells that it rang in the city of Chicago. So it was a really profound event, simply because there were very few people living in that part of what we consider America today. There's an unknown number of deaths, an unknown number of injuries. Actually, the number of articles written about it were limited, just simply because, again, there were very few people who lived in the area who felt it and were able to write about it. Areas that were far more populated did write about it, but it also gave us an idea of how far-reaching the effect of the earthquake was. Um, Now, there were some reports of actually the flow of the Mississippi River reversing course, and that didn't exactly happen, but it created that illusion just simply because of how wave motion changed or was produced because of the sudden movement of the earth, how topography changed. So it did create the illusion, but it just reminds you of just how substantial the earthquake was. And so let's kind of go through the three earthquakes quickly. December 16th, 1811, about 2 a.m. Estimated moment magnitude somewhere between a 7.5 and a 7.9. Um, uh, the epicenter was northeast Arkansas. You can see where the moment magnitude intensity of a 7 to 11, Evansville, Nashville, Louisville, Little Rock. And then New Orleans was moment magnitude more of a 3 or a 4, but felt as far east as Charleston, Savannah, Cleveland, Detroit, Washington, D.C. And if you look at the image in front of you, you can see modified Mercalli scores, giving you an idea of just how far away this was felt. The New Madrid earthquake in January of 1812, again, moment magnitude in New Orleans of a 4 to 5. Um, Again, a moment magnitude of 6 in Charleston, South Carolina, felt in Toronto, Canada, Baltimore. So again, it gives you an idea just how far-reaching these earthquakes can be. And then the last of the series of three truly substantial earthquakes was February 7th of 1812. Again, there were hundreds of earthquakes that took place. There were aftershocks, really, that took place in the next 35 years following this event. So you can imagine how frightening this was to the people then. Honestly, if it occurred today, how frightening it would be today and how much ongoing damage would occur today if something like this were to repeat itself. And please understand that the tectonic plates that released the pressure that led to the earthquake in 1811 and 1812, that plate is still there, that pressure is still there. It's just these are more brittle plates. They're not moving as quickly as the San Andreas fault, and that would suggest that the San Andreas fault is moving fast. It's not, but it does remind you of how over time this pressure can build up and can express itself in a release that causes that type of substantial damage. And this, again, just gives you a little bit more of truly the impact of where the moment magnitude is, and then how far reaching through modified Mercalli we can see how far it was felt and what type of impact occurred. This is just graphically a better image than some of the others that we saw. Krakatoa is, at least for the last 300 years, the most profound earthquake and volcanic explosion that's taken place in the history of the planet. There were a lot of things that dramatically changed in the aftermath of Krakatoa. And let's kind of go over this. Now, let's start out with where is that? So if we look at our image here, this is Jakarta. This is the island nation of Indonesia. Krakatoa is a small island out here in the strait to the west of Indonesia. If we zoom out, we see that it is obviously, a long way away from either the English Channel or South America. But Krakatoa was a volcano that was, as it came to life, had a number of substantial earthquakes leading up to what became a, a really profound volcanic explosion, earthquake, and subsequent tsunami. Killed approximately 37,000 people. The thing that I think we all need to come to terms with is how much of a change to weather patterns took place over the next 20 years because of this enormous release of content into the atmosphere. The tsunami wave, at least close to the original point of where the wave was created, was approximately 100 feet tall in height. It was the loudest sound ever recorded on the planet. It was heard 3,100 miles away, ruptured eardrums on sailors 40 miles away. The shock wave created wave action 7 times around the world, and that wave action was actually measured in the English Channel. The recorded rainfall in 1844, the next year in Los Angeles, was 38 inches, San Diego 26 inches. By 1888, a number of blizzards occurred in the United States that were attributed to how weather changed because of the Krakatoa volcanic explosion. 400 were killed in New York and Boston. More than 100 school children were stranded in schools in the Midwest and died from exposure. It snowed in New Orleans on Valentine's Day. There was a blizzard during Mardi Gras, 8 to 10 inches of snow in 1895 in New Orleans. Just to understand, if Krakatoa occurred today, how substantial the amount of debris that went into the atmosphere, how it altered the Earth's climate, at least for a temporary time period, and what that may lead to today. How would that change air travel? How would that change our world, at least on a temporary basis, and how would we react to that? 67% of the island was destroyed by the volcanic blast. Only 10 inhabitants of the island survived. There was no sunlight in the area for 3 days. There were bodies that washed ashore in South America and Africa over the next 6 months. And again, geographically, South America and Africa are nowhere close to each other, so it does give you an idea of just how substantial the damage was from this. So with this really dramatic eruption included all of this material that was ejected into the atmosphere, which included a substantial amount of sulfur. That sulfur truly changed the color of the sky, at least for several years. And that's reflected actually in Edvard Munch, his painting known as The Scream. It's really amazing how a painting in Europe could reflect a skyline that was dramatically altered by a volcanic explosion, an eruption in 1883, half world away in Indonesia. Again, just understand the magnitude of how much this changed the weather and changed the climate around the world for really the next 15 to 20 years. So the next earthquake we want to look at is Charleston, South Carolina. It happened at just before 10 p.m. on a Friday evening, August 31st, 1886. Basically cut the city off from the rest of the nation. And again, if we think back to 1886, the way the nation was connected at that point was through telegraph. As people around the country reported feeling the earthquake, obviously the closer you were to Charleston, the more you reported how much damage had occurred, how much you felt of the earthquake itself. But oddly enough, there were no reports coming out of Charleston, and that's how they began to realize that Charleston was probably the place where the earthquake occurred. There were more than 300 aftershocks in the 35 years after the initial quake. The death toll really varies a little bit, but approximately 100 people were killed. There were hundreds that were injured. Again, this looks like the aftermath of any disaster. There's pictures of temporary housing, makeshift feeding locations, and a lot of shelter or a lot of homes that have been destroyed. But this particular quake was also felt in New Orleans. The San Francisco earthquake is probably the one that is the best documented earthquake in the United States, primarily because we just began to understand how to create movies. I do have a number of short videos that I have linked for you to take a look at as it relates to the San Francisco earthquake. Just understand the earthquake occurred about 5 a.m. in the morning. A piece of falling debris at the fire station struck the fire chief, and he died shortly thereafter of a head injury. Because of how command and control functioned in those days, it basically left the fire service leaderless. And while the damage was profound, the thing that really created the true disaster itself was the fires and the aftermath of the disaster. The earthquake led to fires. The fires were spread across the city for a number of reasons that I'll discuss in just a minute. But just understand that there were literally hundreds of thousands of people left homeless and displaced because of the earthquake. And there were thousands killed because of the earthquake. Again, moment magnitude was just under an 8, estimated at 7.9. Modified Mercalli in San Francisco was a 10, 11, and in some places considered a 12. Anchorage, Alaska is the home of the most substantial earthquake ever measured, at least in the United States. Occurred on what's known as the Good Friday earthquake. Occurred on Good Friday, March 28, 1964. Occurred in the capital city of Alaska, which is Anchorage. The capital city of Alaska is Juneau. The largest city in Alaska is Anchorage. But it did occur in Anchorage, killed 125 people. The thing that is important to note is a tsunami caused by that earthquake actually killed people in California and Oregon. There were actually boats off the coast of Louisiana that were sunk because of this earthquake, and water was seen slushing in wells in South Africa that was attributed to this earthquake. So again, when we talk about things that are heard around the world or things that are felt around the world, although we typically hone in on one particular location, it's important to understand how that impacts other parts of the world. And although I didn't mention it earlier, the more we know today, the easier it is for us to explain some of the things that occur and some of the things that are not occurring. In 1906, let me digress just a moment to the San Francisco earthquake. As the San Francisco earthquake was occurring, about halfway around the world is Mount Vesuvius. In Italy, Mount Vesuvius was erupting once again. There were substantial earthquakes in that part of Italy where Mount Vesuvius is located. And because we didn't truly understand the science in 1906, there were people that believed the earth was splitting in half because of the massive earthquake that occurred in San Francisco, as well as the earthquakes that were occurring associated with the eruption of the volcano in Italy. Fortunately, it didn't break in half, but it does give you an idea of sometimes when we don't understand cause and effect, and we don't fully understand the science behind something, we come up with some rather novel explanations for what's occurring. Banda Aceh, the Indonesia earthquake, the epicenter was off of the coast of northern Sumatra. It was a substantial earthquake, moment magnitude 9.1 to 9.3, modified Mercalli of an 11. I'm sorry, 9 to 11. Actually, this is showing up to 9, but if I'm not mistaken from my notes, it's 9 to 11 in the immediate area. Killed 227,000 people over 14 countries. It is important to note that um, the hypocenter, the distance between the hypocenter and the epicenter was actually quite close, and because it was, it expressed itself in a substantial energy release, and because it occurred under the ocean, that created that substantial tsunami. Um, that gives you an idea of where the epicenter was located. Again, please understand that there were people that were killed in Sri Lanka, Indonesia, Thailand, India. So you've got this earthquake that occurs in the Indian Ocean, but it's rippling out into the far western side of the South Pacific, and moving further into across the Indian Ocean to Madagascar and the east coast of Africa. Again, Somalia, 3,100 miles away, had 289 deaths. India had 16,000 deaths. Again, just giving you an idea of just how far-reaching and how catastrophic that particular earthquake-induced tsunami caused damage, death, and injury. The Kashmir earthquake in Kashmir is a disputed territory that exists on the border between India and Pakistan. That was actually the epicenter. A substantial amount of damage occurred in Pakistan. And so it's important to note that there were, again, 87,000 killed. The hypocenter was about 9 miles below the epicenter. And so modified Mercalli was substantial, and moment magnitude was 7.6. Again, the earthquake was felt across a substantial amount of Southwest Asia, India, Pakistan, China, and then up into Tajikistan, and I think Turkmenistan. I'm not sure if I have it on my slide, but anyway, Uzbekistan, Turkmenistan, Tajikistan, and Pakistan, and Afghanistan, obviously. The Haitian earthquake was 2010, January of 2010. The Haitian earthquake had three things that conspired to create this really dramatic disaster. Number one, the distance between the hypocenter and the epicenter was actually very close. It's only about 8 miles. Moment magnitude was not substantial. It was a 7. I mean, that's still a big earthquake, but it's not an 8 or a 9 like we've seen with some of these other examples. But it occurred near Port-au-Prince, which is the capital city, and it occurred in an area that had a lot of dense population, and it also occurred in an area. Much of Haiti has poor building construction. It's believed that somewhere between 200 and 300,000 people were killed, and another 500,000 people were injured. Truly catastrophic event and a truly substantial event. Just some images of what Haiti looked like in the immediate aftermath. I had some friends who were a part of the response to the Haitian earthquake, and I actually was involved in movement of some patients that were repatriated Americans coming back to the U.S. for injury care. This is their Haitian capital. Just again, in the aftermath of an earthquake like this, all hands on deck, and everyone's trying to help to effect the rescue. But when you build a lot of things out of concrete, you don't use a lot of reinforcing rebar. You have a lot of concrete slabs that come down, and it creates a truly substantial event to have to deal with in terms of the rescue in the aftermath of a disaster such as this. The Chilean earthquake occurred in 2010, actually shortly after the Haitian earthquake. Um, Moment magnitude was 8.8. So if we think back to moment magnitude in the Haitian earthquake, which was a 7.0, why did they only have 500 that were killed? There was a substantially greater amount of energy that was released, but there were several distinct differences. Number one, because Chile had a really substantial earthquake in the 1960s, they had built back with a much better building code. And so the structures that are built in Chile today comply with a much stricter building code, and that was what handled a substantial amount of the load. Now, there were still people who lost their lives, there were still buildings that collapsed, and there was a small tsunami that was produced by this, but it was nowhere near what could have occurred just simply because of a couple of things. Number one, the difference between the hypocenter and the epicenter was substantially greater than it was in the Haitian earthquake, and the construction was much better. Um, and this is just some images from the Chilean earthquake. You know, the Chilean earthquake concerns us because in 1960, a magnitude 9.5 earthquake occurred. 9.5 was actually the greatest ever recorded in the Americas. Depth was 33 kilometers. Maximum intensity was a 12. There were over 100 people killed in Hawaii and Japan because of the tsunami that was produced by the 1960 earthquake. And so when I talk about the 2010 earthquake in Chile producing a small tsunami, it did produce some wave action in Hawaii. A tsunami alert was issued for Hawaii, but it only wound up with wave action of about 6 to 8 feet, as opposed to a wave action of 30 to 40 feet as occurred in the 1960 earthquake. You know, so let's kind of finish this up with things to do and things not to do. Um, Drop where you are, find a place that is safe that you can get under and shelter in place. Um, there are things that we want to protect. We want to protect our head and neck. If there's a sturdy table, crawl under that table. You really want to be in an area where you can protect yourself, and you want to be under something that's substantial in nature. It is important to protect yourself. It is important to try and get people away from the exterior walls, away from the windows. But you need to take immediate action as soon as you start feeling this earthquake, because there's not a lot of time distance between when you first start to feel it and when a significant amount of the shaking begins to take place. Hold on. It will pass in a fairly short period of time. It may seem like forever at the moment, but it will pass in a fairly short period of time. But again, as quickly as possible, find a table, find something substantial in nature, and get under it and move away from the window. Um, there once was a time that we thought about standing in a doorway, and we used to tell people probably the safest places in a doorway, and it came from a home that partially collapsed that was made of adobe, and the wood frame was the only standing part. Um, the reality of that is, unless you live in an adobe uh, earthen type mud brick house, um, standing in a doorway does not produce any more safety than any other part of the building. You want to be under something substantial, and you want to be away from the exterior walls and windows, and that's typically a table. You're much safer under a table than you are in a doorway. Don't run outside, and the reason we tell people not to run outside is because the facades, the outside part of the building starts to peel away, pieces start to fall, and unless you can run quickly to the park, and I don't think you can make it that far before things start falling off of the building, you're not going to be out of danger. So you're probably safer in the building. You're probably safer under a heavy table, and just hold on until the shaking passes. The data we saw in the aftermath of the Haitian earthquake was early on, we saw a lot of injuries related to the earthquake, but really within about the fifth day, the sixth day, the injuries that we saw were really people trying to recover from the earthquake as opposed to injuries related to the earthquake itself, or some injuries occurring just simply because of all of the debris and everything else that was going on, the stress that was involved, loss of water, loss of reliable food sources. There were a lot of other reasons why we saw patients in the aftermath of the Haitian earthquake rather than injuries related to the Haitian earthquake. Most victims will be rescued within the first 48 hours. Most injuries will occur early on, and the thing we need to think about in terms of self-care and buddy care, how do we protect ourselves? How do we take care of ourselves? How much do we wait for people who are trained versus how much do we do ourselves to try and rescue someone? Most people are rescued by Good Samaritans rather than search and rescue teams in the aftermath of an earthquake. It takes a while to mobilize those types of resources, and it's very difficult to break through different types of structures to get into where they are. There are certainly success stories that are out there, and we certainly we as in the United States send urban search and rescue teams to other countries when there are earthquakes, and we have those teams available here in the US when earthquakes occur. Just understand it's very difficult to effect those types of rescues. If we can help people get out, we need to try and do that. But in many cases, they may be trapped, and it may be well beyond our technical expertise to get them out. Again, as far as types of injuries, crushing injuries, fractures, some penetrating injuries, and some burn injuries, just simply because of the nature of how things occur in the aftermath of an earthquake. Rescue, evacuate the area, avoid the buildings that have been damaged, and then some of the same things that we would normally do. Always be sure that we're thinking about the types of injuries that we would associate with an earthquake, such as fractures, puncture wounds, and injuries that may produce bleeding, and then how do we manage those accordingly. In terms of home and business strategy, if you're going to live in an area that has a rating for substantial earthquake exposure, tempered glass, window tinting film does a good job of holding the glass together, secure items to the wall. You don't want to just hang something on the wall. You want to be sure and secure it to the wall. And that includes additional strapping to any type of pictures or any type of something that you're going to hang on the wall. If I lived in the Seattle area, as an example, I would screw things to the wall rather than hanging them like we would normally think of hanging a picture here in New Orleans. Plan to evacuate where your rally point would be. If you're a business, do you have an emergency website? We refer to that as a dark site. That's something that you can pre-build and have operating in the background that you don't turn on until you have a disaster, whether it's with an earthquake or a hurricane or anything else. If you need an emergency website, talk with your webmaster about building a dark site and what are things that you would put on it, so that if you did have a disaster and you needed to provide this resource for your employees to find out things about what they need to do in terms of protecting themselves or coming back to work, or but an emergency website is a good business strategy to have. Coop planning, continuing operations. How do you manage your supply chain? How do you manage your distribution? And then seismic construction. What did your the building you're in, how is it built to withstand certain seismic activity? Again, not a lot of buildings in New Orleans have met seismic requirements. The hospital at University Medical Center has met seismic requirements. If you're in Memphis, a lot of the new buildings in Memphis have met seismic requirements. Areas that are in the New Madrid Fault area have met seismic construction, but those are only newer buildings. If you're ever traveling on the interstate near Memphis, look at some of the seismic retainer straps on bridges overhead. You'll see some really interesting construction that's there in place to help hold the bridge together if that area was impacted by an earthquake. And that's it. If you have questions, as always, send me an email. I'm available at this email address. My contact information is on Canvas. But otherwise, that's it. I hope you have a good day. Thanks.